Let us discuss another semi-supervised systems for word sense disambiguation, which is called Yarowsky algorithm. Yarowsky algorithm is a semi-supervised algorithm for word sense disambiguation. It is because we are calling it semi-supervised because we start with the labeled data, small amount of labeled data. Sometimes we call it seed data. Then we gradually, iteratively train that using a classifier. So the base of this algorithm is whenever we have a collocation, a nearby words, when we have a set of nearby words, that word will have one sense. For example, if the plant is ambiguous, so the nearer words are like life, cell, then this type of greenery, water, then this is talking about biological plant. Otherwise, when we talk about manufacturing product factory, then it is talking about industrial plant. So based on the nearing words or collocation, there will be one sense. When we have life and cell, we don't get industrial sense. That is the first point. The second one is whenever we are talking a conversation, one discourse, for example, when we are talking about cricket, the word bat indicates the batsman using the bat, not about the bird bat. So in the discourse about cricket, the bat has only one meaning, that is the instrument used for playing cricket. For example, I'm talking about sports. Rocket means the instrument used by the tennis player. It is not talking about a satellite rocket or Diwali rocket. So if I talk about Diwali, then the rocket fireworks, the rocket will have Diwali rocket. So based on the discourse, there will be one sense. So the principle is one sense per collocation, one sense per discourse. Based on that, the first step in this algorithm is identify the instances of the word. So from the text corpus, find all occurrences of polysemous words. What is polysemy? One word having the same spelling, same pronunciation, giving related or non-related meanings. So store each occurrence along with its constant. For example, the word plant, it may occur in industrial sense, the manufacturing, then another one biological sense, the plant cell has a nucleus. So the plant has two senses, one is industrial plant, another is biological plant. So store that in along with the context. The second one is identify the representative instance. Identify a small set of instances that clearly represent one of the sense. So this is called a seed set. We take manually annotated example where we have the clarity and clear-cut annotation. Now we have biological plant. The collocations are life, cell, photosynthesis. Industrial plant, the collocations are manufacturing, factory, and production. So identify the representative instance. Then train a supervisor classifier using this manual annotated seeds. Because already we have labeled the data, train that, and classifier learns to associate collocates with specific meaning. Suppose example, photosynthesis cell is there. So it know that it is a biological plant. Factory manufacturing is there. It will be trained that it is industrial plant. So this is training phase. Then once we finish done with training, we classify new instances, test data, and use the trained classifier to label remaining instances of the word. Only label instances the classifier is confident about. Then once we're done with, we may have some potential misclassifications in the test data. Then check the principle one sense per discourse. So from that or one sense or per collocation, remove the misclassifications. For example, if a plant is consistently used in biological context, we can add new collocate like chlorophyll, organelles, these things. So repeat the process iteratively to expand the seed data and refine the classifier. Each iteration will make the classifier more accurate. And once this is done, stop and apply the classifier. Continue until only a small stable residual remains. Use the trained classifier to classify the new data. Another algorithm, uh, which is also unsupervised and supervised combination, we can call this as semi-supervised, Mihalcea and Moldovan algorithm. So this combines both unsupervised and supervised techniques, and it uses resources like Wikipedia or WordNet. It is the aim of this algorithm is automatically generate sense tagged data instead of manually annotated. So the first step in this algorithm is search all sentences in Wikipedia where the target word is a link. For example, in this here we are talking about a word called bar. Bar may have different notations. Bar may be a drinking place, bar may be a musical notation, bar may be association of lawyers, legal word. There will be metal bar, something like a rod. So there are four senses: drinking place, musical notation, legal profession, piece of metal. This is the ambiguity with that. So here we have two types of links. One is simple link where directly it talks about an object. Bar is a metal object, something. Then there is a piped link, musical notation and bar. So this bar refers to the link musical notation. So identify these links. Then filter disambiguation pages. Remove the links pointing to disambiguation pages. If a word does not point to a disambiguation page, it is considered a valid label. There is no disambiguity. Whenever there are piped links, the string before it, that means musical notation or legal profession, that serves as a label. So collect all the labels and map it to the word net. So collect all labels from the Wikipedia links, map these labels corresponding to WordNet senses. If the all labels map to the same sense, then the word has only one meaning called monosemous. If the labels map to multiple WordNet categories, and we can use it for sense disambiguation. Step 4, generate the training data and map the Wikipedia's data to WordNet. So this mapping is very cheap. We need not have much computational expense for that. For example, you have bar. We have four senses: sense 1, sense 2, sense 3. So once Wikipedia word is given, these are linked, mapped to sense 1, sense 2, sense 3, sense 4. So this method is very effective because it automatically generates sense tagged data without using manually annotated. Then generally this disambiguation accuracy is reported around 80% and inter-annotator agreement is around 91%.